Hi Pre-Cal, it's Ms. Kosh. I am looking at the notes from section 1.3, the rates of change. I may not do every little bit of it, but I want to talk through a few things. So first of all, what happens if it's a linear function, then we're going to have the same rate of change. So if you had an equation that was a line, it's got whatever the slope is, that slope is constant the whole time. So if I pick 2 points right here and I find the rate of change, that's going to be the same thing as if I had picked a point here and here, or wherever, or if I'd gone the rate of change from this to this. That slope would be constant throughout. So when I look at my table, I can say, okay, well, this is adding 3, this is adding 3, this is adding 3. Oh, we think, oh, look, the first difference, that means it's linear. But the catch is that this one we don't have the equal we don't have equal values for x here. So this would not be a linear function because the rate of change from when x goes from 1 to 2 over that interval, it's 3. The rate of change when we go from 2 to 4, it's 3 over 2, which is a different rate of change. I don't know that I really want to do this problem in the video, so sorry. What they do, so one of my colleagues or somebody, I don't know exactly, came up with some great stuff to help us figure out how to do this in our calculator. I haven't looked at it. Let me just show you. This might be good and helpful, but I'm going to skip this page. What we're going to do instead is, if you notice in my answer key, I don't really talk about the function pattern. It might be great. It's just not my style. What I'm doing is I'm recognizing we add 1, we add 1, we add 1. Okay, so that's promising, but I have to look over here. Oh, sure enough, to go down this one, I'm also adding 1 each time. So what's this type? So we were consistent in what we were adding for x. We had our first difference here was the same all the way down, so this is linear. So the function type is linear. One option is for me to recognize that here is my y-intercept, and my slope is 1 over 1. My slope is 1. So when I write the rule, y equals, or I should say maybe f of x equals, either way, we had a slope of 1, so we can just write x plus a y-intercept of 4. And we could double check, plug in 2, yep, I get 6, and so forth. Now, if we were not sure what to do, I can come here to my calculator, and I can come over to statistics. I just cleared my memory so we wouldn't have extra stuff. I can plug in -2, -1, 0, 1, and 2. Come over, type in list 2, 2, 3, 4, 5, and 5, you weren't there to correct me, 5 and 6. And so when I graph that, it defaults to doing those like that. If I need to, when we come back here, I can set the graph in different ways, but its default made me happy, so I just knew to go with that. So go graph, exit, okay, graph. And so now I can calculate, I know that this is going to be a linear regression. I can calculate this, ax plus b, and sure enough, y equals 1x plus 4. But we already knew that one because that one was easy. The next one, let's see what's happening. Oh, on this one, this doesn't exactly fall into the unit here, but what I'm noticing is that I'm multiplying by 3 to keep going all the way down. So this is going to be exponential, and my rule is, well, I see that I'm multiplying by 3, so I'm going to have something 3 to some power. If I plug in 0, I am getting, well, basically what this did is all of these are nice, beautiful powers of 3, but I want to be able to plug in -2 and get my exponent here to be 0, because anything 3 to the 0 power is 1. So I'm going to put x plus 2. That is hard to see. So f of x is equal to 3 to the x plus 2. Basically what it did is it took my normal parent function. We're going to talk about this later. But it took my normal parent function and it moved it 2 units to the left. So try plugging in a number. 2 plus 2 is 4. 3 to the 4th power, sure enough, is 81. Let's see, is the next one? Okay, I think the next 2 are good to talk about. I added, notice I'm going 1, 2, 3, 4, that's whatever. 0, 1, 2, 3, 4, but that's good news. This we added 6, we added 8, we added 10, we added 12. So this is not linear. The first differences don't match, but the second differences do. So this is quadratic. Now, when I started doing my answer key last night, I didn't have a calculator at home, so I used systems to solve for this. So what I did is I came over and said, then I know my equation is going to be quadratic. It's going to be f of x is equal to ax squared plus bx plus c. And so I knew that the first one, I picked easier values to work with. So f of 0 is going to be a times 0 squared plus b times 0 plus c. This is 0, this is 0, this is c, and it's going to be equal to -6. So I knew my first variable c had to be -6. Then I picked another one. F of 1 is equal to a times 1 squared plus b times 1 plus c, and that's going to be equal, f of 1 was equal to 0. So I had a plus b minus 6, because we already know what c is equal to 0. So I have a plus b equals 6. And then I kept going and I solved for a and b. But this video is going to get too long. You can keep practicing that, and you can go check my answer key and see what you get. Oh, I'll do a little bit more. I'm sorry. A times 2 squared plus b times 2 plus c is equal to, oh, nope, not 0. It's equal to 8. I was just testing you. And so on this one, I have 4a plus 2b minus 6, because we know that c is equal to -6 is equal to 8. So now I have 4a plus 2b is equal to 14. I can divide everybody by 2. 2a plus b equals 7. And now I'm using these two to solve a system. Let's go ahead. Let's multiply through by -1 right here. So I have 2a plus b equals 7. A minus b equals -6. I can do elimination. A equals 1. When I plug that back in, b would equal 5. Either way I do that, b would equal 5. So my equation is y is equal to 1a x squared plus 5, so it's ax squared plus bx plus c. A was 1, b was 5, c was way up there. You can't see it anymore, -6. Okay, now that was a little ridiculous. Let's let the calculator help us. So I come back here. I still have good x values. Nope, that's wrong. So I don't have good x values. I'm going to come up here and hit delete. Where is it? So delete, I can, delete all, that list, and then I can come over here and delete all, and now I have a clean slate to work with. And I want 0 to 4 in my x values. And I want -6, 0, 8, 18, and 30 in my y values. And I can graph that. Okay. Then I can calculate. I expect this to be quadratic, so I'm going to hit the x2. And so notice this was 1 was a, b was 5, and c was -6, which is what we found the hard way. What did we say? So this was quadratic, which we knew because the second differences were constant. And then the function rule, f of x was equal to x squared plus 5x minus 6. Okay, isn't life good? Next one over here, we're still adding 1 the whole way down. That's good. We're adding, what is that? Oh, no, we're subtracting. We would subtract 6. We would subtract, so that's, I think we subtracted 36. Here we're, oh, y'all, I'm exhausted. So I think we subtract 18. We subtract 6. Oh, we subtract or add 0. So now from here to here, from negative, that is not constant. From here to here, we added 18. We added 12. We added 6. So it's not linear. It's not quadratic. Now let's see. From here to here, we subtract 6 to go from positive 18 to positive 12. We subtract 6. Oh, those do match. It would really be helpful to have more information when it's cubic, but that does work for us. So this function is cubic, and I can do the exact same thing with the system. It's kind of a fun exercise if you like to practice solving systems. You can check my answer key because I was doing it at home while watching TV last night. But it's cubic, and I'm going to come over here. I'm going to come back to this. I'm going to come back, delete all, come over here, delete all, and I'm going to type in this new one. So it was -4, -3, -2, -1, 0. Notice I did check on all of these x's that they were increasing or decreasing at a constant rate. 34, and they were. So I didn't write it down. 10 and 10. Okay, so now I can come over here to the graph this one. Okay, and we're going to calculate. We expect this to be cubic. And that looks, okay, the calculator doesn't know what it's doing. The calculator, well, it kind of does. This is supposed to be a -1. Okay, so watch this. I can copy that into y1. And then when I do, well, what they're telling us here is that f of x, this is really just a negative 1x cubed. We have, this is really just 0. It's a ridiculously small number because the calculator got confused with pixels and it's supposed to be 0. So then this is plus x plus 10. So if I come over here, menu, to my graph, it copied that. I have to turn this one on, so I have to select it. But let's type in what they gave and then what I just wrote down, how I interpreted that. Negative x to the third plus x plus 10. And when I draw that, notice they're the same. And if I'm really not sure, I can go back to, where am I? Menu. I can go back to the table and I could look at a few of the values. Is it on? Turn that on. And notice they're all matching up beautifully. And I could keep going. I could plug in, I don't know, let's pick a number. My birthday is 6/17. Okay, that's ridiculous, but they match. So see how that and that are the same. Hopefully that was helpful. My suggestion for this next section is to turn it into a table with x and y values. So we would go 0, 8, 1, 3, 2, negative 4, 3, negative 13, and so forth. I wrote too big. I don't know that that's worth making a video because I think those two are very similar to what came. I didn't bother with the function pattern because it's not how I think. Okay, I'll make a video about this last little bit. So good luck, go practice. Let me know if you have any questions.